Hello everyone, good morning. In today's class we are going to cover limit laws. In preceding sections we used graphs and calculator to guess the limit of a functions, and here we use some basic laws to compute the limits of a functions. So let me start. So here k represents the constant. Special laws: limit of a constant k as x approaches to a is constant k itself. 2. Limit of x as x approaches to a is a. 3. Limit of x to the power n as x approaches to a equals to a to the n, where n is a positive integer. Let's continue. Constant law: limit of the constant times the functions is constant times the limit of the functions. Sum law: limit of the sum of the functions equals to sum of their limits. Next, the product law: limit of the product of functions equals to product of their limits. Quotient law: limit of the quotient equals to quotients of their limits. Obviously here, provided the limit of this denominator, function gx as x approaches to a is not 0. And this requirement is necessary here because when you define the fractions, we want to avoid 0 in the denominator. Next, the power law: for n a positive integer, limit of the functions f of x to the power n as x approaches to a equals to, first take the limit of the functions f of x as x approaches to a and then take the power n. Next, the root law: for n a positive integer, limit of the nth root of functions equals to nth root of limit of the functions. So that means here we can send this limit inside to the functions. First take the compute the limit and then take the nth square root. There is a lot here. Limit of the functions does not exist, then the basic limit laws cannot be applied. Okay, let's continue. Squeeze theorem. Suppose we have these two inequalities here. Functions fx is less than or equals to function gx. Function gx is less than or equals to function hx for all x close to a, and limit of the smallest functions f of x as x approaches to a is L, and the limit of this largest function hx as x approaches to a is L, the common value here. Then the limit of this middle function gx as x approaches to a is L. Some useful limits. Now we learned these basic limit laws. Now let's implement those basic limit laws and compute some of the limits below. So let's start the example 1. Evaluate the following limits. And here we're not computing left limit or right limit. We are just using the basic laws. We just went over here to compute the limit of the functions. So here, A, compute the limit of the functions 3x minus 7 as x approaches to 4. So here our function is the difference of the two functions. One function is 3x, another function is a constant 7. Now we use the properties here, the sum rule: limit of the sum of the two functions or limit of the difference of two functions equals to sum of the limits or difference of the limits respectively. So now for our case we are using the difference here. Okay, let me scroll down. So the example A here. So the left-hand side limit of the difference of functions 3x minus 7 as x approaches to 4 equals to, by our difference laws, limit of the 3x as x approaches to 4 minus limit of the constant 7 as x approaches to 4. Then next step, plug x equals to 4. So then 3 times 4 minus limit of this 7 as x approaches to 4. This is the constant function, so constant doesn't change, so 7 itself. Then do the last one here. 3 times 4 is 12 minus 7 equals to 5. So our answer for the limit questions A is 5. I hope it makes sense. Okay, so let's continue. Questions B. Limit of these functions 2x cubed plus 3x squared minus 7 as x approaches to 1 equals to. Now here in our equations we have sum of these two functions and we have the difference of another function there. So these limit laws we can apply to any number of sum or difference of functions. So then the next step is limit of 2x cubed as x approaches to 1 plus limit of 3x squared as x approaches to 1 minus limit of 7 as x approaches to 1. So then here 2 plug x equals to 1 cubed plus 3 put x equals to 1 square minus excuse me 7 constant as it is. Then you simplify. Here is a 2, here is a plus 3, here is a minus 7, so answer is negative 2. Okay, let's continue. Now we have question number C, different functions here. Limit of this quotient 3x over radical 4x plus 1 as x approaches to 2 equals to limit of the numerator over limit of the denominator. And the next step, on the numerator, we just plug x equals to 2, so then 3 times 2 here. And in the denominator, we can send this limit inside the radical. So we have radical, then the limit of 4x plus 1 as x approaches to 2 becomes 4 times 2 plus 1. Simplify. Cancel the common terms in the numerator and denominator. It gives us the answer is 2. I hope it makes sense so far. So let's continue. When denominator approaches to 0, use algebraic simplifications. Cancelling factor means graph has a hole. So for example, let me scroll down. Example D. Limit of these fractions x squared plus 2x minus 3 over x minus 1 as x approaches to 1 equals to. If we put the value directly here in our denominator, then this x minus 1 becomes a 0. So that means we don't want 0 in the denominator. So let's use for some algebraic simplifications. So numerator, we can factor x squared plus 2x minus 3 as x plus 3 and x minus 1. Then in the next step, we can cancel the x minus 1 in the numerator, 2x minus 1 in the denominator. Keep in mind, here x minus 1 is not equals to 0 because limit here is x approaches to 1. So we can cancel the non-zero terms there. Then we have left over is just the x plus 3, no more fractions. Then just plug the value, the last step here. So x equals to 1, then x plus 3 becomes 1 plus 3, which is 4. Good. Next example. Sometimes we need to rationalize the numerator or denominator by multiplying the whole fractions by the conjugate of the radical term. So example E. Limit of these fractions, radical of 9 plus x minus 3 over x as x approaches to 0. Again, when x goes to 0, the denominator becomes 0. That means we need to do some algebraic trick here. So the algebraic trick is, in our numerator, we have radical 9 plus x, outside minus 3. So now we are multiplying and dividing by the conjugate of radical 9 plus x minus 3. So the conjugate here is simply change the minus sign to plus. So here, this is the conjugate of radical 9 plus x minus 3. We multiply, so divide by the same expressions. Then in the third step here, copy the limit as it is. And the numerator, when we multiply radical 9 plus x minus 3 and radical 9 plus x plus 3, it gives us 9 plus x minus 9 over, I'm just copying the denominator as it is, x times radical 9 plus x plus 3. Now let's simplify the numerator here. The 9 cancels, and then we have x left, then this x, and then the denominator x cancels. So we have in the fourth step here, limit as x goes to 0 of 1 over radical 9 plus x, and then plus outside 3. Then put x equals to 0, simplify, it gives us the limit of this given questions in E equals to 1 over 6. I hope this idea makes sense. Let's continue. Let's do another example where we use the squeeze theorem. Let me take you up when we define the squeeze theorem here. So for the squeeze theorem, we do need this inequality of 3 functions and one more conditions. The smallest function or the largest functions approaches to the same limit. Then the middle functions also approaches to the same limit. Let me scroll down. Here, compute the limit of this trigonometric function sine x as x approaches to 0. Now to compute this limit, we need to find out the bounds for these sine functions. And if I take you to this diagram here, the absolute x is this red graph, and absolute negative x is this dash graph, and sine function is in the blue one here. So that means we can bound the sine functions by these absolute value functions, and our goal is to look or observe near the origin, because the limit is x approaches to 0. So that means let's start the solutions here. So we know this one, sine x is bounded by absolute value functions x and negative absolute value function x, and we know the limit of this absolute value functions as x approaches to 0 is 0, right here. That means now this satisfies the hypothesis of squeeze theorem. Then the conclusion is the middle function, means the trigonometric function sine x, also approaches to 0 or has limit 0 as x approaches to 0. Good. And obviously the absolute value functions, we have these 3 pieces here, and we know the absolute value function converges or has limit 0 as x approaches to 0. So I have done here. Okay. Similarly, let me do number G here. Limit of these functions x squared times sine 1 over x as x approaches to 0 is 0, because let me try to use the squeeze theorem for this example also. We know the trigonometric function sine 1 over x is bounded between minus 1 and 1. So the sine function's maximum value is 1 and minimum value is minus 1. So we have this inequality here. I hope this makes sense. And then multiply both sides by x squared, no matter what x is, x square is always positive, so that means still this inequality holds true. So minus x square less than or equals to x square times sine 1 over x less than or equals to x square. And we know this y equals to x square is a parabola opening upwards, and it passes through the origin. So that means when x approaches to 0, sine x square limit is 0. So that means we have left side 0, right side 0. So that then we can apply the squeeze theorem, and hence by squeeze theorem the middle functions x square times sine 1 over x as x approaches to 0 is 0. So this is again kind of a trivial questions here. Okay, now I have a few examples just to do in the classroom. So here is a classwork problem, so please try those problems, and any questions we can go over in the next class. So the first question is limit of these fractions. Second question is here we need to apply the conjugate idea that we did in the previous example. And third one, I think you can just FOIL the numerator and simplify. Then you should be able to cancel the h in the numerator and denominator, and finally you will get the answer -8. And the fourth one, so here you need to factor the denominator and again use some algebra. And question number V here, so we are using the squeeze theorem again here since we have this inequality. I hope you can apply this squeeze theorem correctly and we'll get the answers is 3 here. And 6, again you can use the conjugate of the numerator, multiply and divide by the conjugate of the numerator and simplify. The idea for question number 5 here, this should be 7. You simplify these two fractions, and for next questions you need to use this absolute value functions in the numerator, so which we define here. Use this idea, then you should be able to find the limit of these questions. And then the last questions here, limit as x tends to infinity of these functions, radical x squared plus x minus x. You are multiplying and dividing by its conjugate. You should be able to get the limit. Okay, thank you.